All right, so implicit differentiation, it's a way of finding derivatives. What we're used to is equations that are in something called explicit form. An explicit form means y is by itself. So like y equals 3x cubed minus 6x plus 7. And these are really easy to take the derivative of, because what's the derivative of y? Y prime, right? Don't we call it y prime? Derivative of y prime. Okay. And that's equal to, what's the derivative of 3x cubed? 9x squared minus 6 plus 0. Okay. So there's my derivative. Okay, now other equations don't have to be written in explicit form. They can be written in something called implicit form. And implicit form is something that looks a lot messier, like xy minus 2x squared plus 3y cubed equals 6x minus 7y. And it's implicit form because the x's and y's are just mixed up. Okay, there's x's and y's on both sides of the equation and y's not by itself, and it's called implicit form. And usually our goal, what you've always been told to do, is get y by itself, right? Get y by itself, get y by itself. Well, guess what? Trying to get y by itself here could be a really big challenge. Okay? And actually, we don't even need to get y by itself to take the derivative. So, in order to be able to take implicit derivatives, or derivatives of implicit functions, implicitly written functions, functions that have the x's and y's on both sides, we are going to be asked to take derivatives of these today. And we don't have to get y by itself to do that. But we have to get one thing, one concept through our head in order to help us understand how to take an implicit differentiation, and that is the chain rule. Okay? Remember how I said the derivative of y? What's the derivative of y? Y prime. That's if it's just y. Okay? So the derivative of y is what we need to get past. We have to get over the hump, the derivative. How do I find the derivative of y? And not just y, but anything with y. So, how would I take the derivative of 3y cubed? Or negative 7y? Or how about xy? Anything that involves y is not, it's different, because y is typically assumed, to be a function of x. In other words, y is assumed to equal something that has an x in it, right? So when I say what's y, you assume it's like some equation like 2x minus 4, or the square root of x. So what we have to assume in our head as mathematicians, and if I'm finding this derivative, that y is some other function out there that we don't know. So what actually we're dealing with in a problem like negative 7y to take its derivative, y is some inside function. So like this would, this would even be a better one. If I'm taking the derivative of 3y cubed, y is assumed to be some secret function that I don't really know, like sine of x. And if I were going to take the derivative of 3 sine cubed of x, I would have to use the chain rule, because it would have an outside function, the 3 times something cubed, and the inside function, whatever y equals. So the way you have to treat a derivative of y is you have to use the chain rule. The derivative of, so like let's say I want to take the derivative of in terms of x. Remember, derivatives are always in terms of x, well, most of the time. It could be in terms of theta or t. But the derivative of y, other notations to write, remember, are the derivative of y, you could write y prime. Could you write dy over dx? Doesn't that mean the derivative too? The derivative is always in terms of x. So if I want to find the derivative in terms of x of 3y cubed, here's how I have to do it. I take the derivative of the outside function, which is what I see outside the y. So what would be the derivative of 3y cubed? Just leave it like, what's the derivative of 3y cubed? 9y squared. Okay, see how we did that? Just pretended it was an x, took the derivative. Now we have to assume that we have a chain rule. So that was the derivative of the outside times what would be the derivative of just the y? Y prime. What's the derivative of y? Y prime. So anytime you're going to do an implicit differentiation problem, okay, you're going to do one of these, it has x's and y's all mixed up. Whenever you take the derivative of y, whenever you take the derivative of y, something that has y, the sine of y, the cosine of y, the secant of y, 5y cubed, anything that has a y in it, you take the derivative and then times by y prime. Take the derivative, then times by y prime. So if I wanted to find the derivative in terms of x of the cosine of y, the derivative of the cosine of y, well, what's the derivative of the cosine of something? Negative sine of y times the derivative of y, which is y prime. Take the derivative, then times by y prime. Okay, take the derivative and then multiply by the derivative of y, which is y prime. Yep.